वो इंट्रोडक्शन वाली स्लाइड से हाँ Good evening, one and all present here. Today, our group is going to present on the topic wearable health devices. The group members are Khushi, Rishabh, Shreya, Ashwin, and I, Apritim. Next slide. Next slide. So here you can see the contents of a presentation such as introduction and the various devices which we will be discussing today, their future scope and conclusion. Next slide. Let's begin with the introduction. What wearable devices are? Wearable health devices are electronic gadgets that we wear on the body to monitor health in real time. They're a blend of technology and healthcare designed to give us continuous updates about how our body is functioning. Some common examples include smartwatches, fitness bands, continuous glucose monitors, ECG devices, and even smart rings. What makes them different from traditional medical tools is that they just don't just provide one-time measurements. Instead, they continuously record vital signs like heart rate, oxygen saturation, physical activity, and sleep patterns. This constant monitoring means health issues can be detected early, sometimes even before symptoms become noticeable. That's why wearable devices are considered an important step towards preventive healthcare. Now we'll discuss some of the commonly used health devices. Next slide. So first we have smartwatches and fitness bands. Among all the types of wearables, smartwatches and fitness bands are the most widely used. They are lightweight, easy to wear, and integrate multiple sensors into a compact device on the wrist. They track parameters such as heart rate, SpO2, sleep quality, and steps taken. The importance of these devices lies in three main areas. First, they help detect abnormalities early, for example, an irregular heart rate or unusual sleep cycle. Second, they encourage healthier lifestyles by setting fitness goals and giving reminders. Third, they support remote healthcare because the collected data can be stored on mobile apps or cloud platforms and shared with doctors whenever necessary. In short, smartwatches and fitness bands transform simple health tracking into continuous and meaningful monitoring. Now we will discuss the working principle of smartwatches and fitness bands. The working principle can be explained in three stages. First, sensors. These devices are equipped with different sensors. An accelerometer and gyroscope measure motion, steps, and posture. A PPG sensor uses light absorption to measure heart rate and oxygen levels. Some models even include temperature sensors to track changes in skin temperature. Second, data processing. All of this information is collected and processed by a microcontroller inside the device. The raw signals are analyzed to identify patterns and trends, and the processed data is displayed either on the watch screen or synced to a smartphone application for further analysis. Alerts and insights. Finally, the real benefit is interpretation. The device can generate alerts such as when it detects an abnormally high or low heart rate or irregular sleep. Along with alerts, it also provides actionable insights to guide the user in maintaining fitness and preventing health issues. This combination of sensors, processing, and intelligent feedback is what makes smartwatches and fitness bands powerful tools in modern healthcare. Next slide. Now we'll discuss examples and benefits. Some of the commonly used examples are Apple's Watch series, Fitbit Charge series, and Samsung Galaxy watches. Benefits include continuous non-invasive health monitoring, help in early detection of different diseases, and it encourages a healthy life cycle through activity and sleep tracking, and data can be shared with doctors for remote healthcare support. Now we'll have the first question of our presentation. First is which combination of sensors in a smartwatch allows it to track both movement and vital signs simultaneously. So here you can see four options A, B, C, D. In the next slide, we'll see the answer of this question. Next slide. The answer is option A, accelerometer, gyroscope, PPG sensor. Now I'd like to call Risha for the next device.
So now we'll see what is continuous glucose monitor, CGM. So continuous glucose monitoring, CGM, is a wearable device that continuously measures glucose levels in the interstitial fluid under the skin. It provides real-time reading, trend, and alerts. CGM is mainly used by the people with diabetes to track blood sugar, adjust insulin, diet, and lifestyle. It prevents sudden highs and lows and improves long-term glucose control. Now we'll see the working principle behind it. So the first, sensor insertion. A tiny sensor with an enzyme coating, usually of glucose oxidase, is inserted under the skin. The sensor tip stays in the interstitial fluid. And next, the enzyme reaction. The glucose from the fluid reacts with the enzyme glucose oxidase on the sensor. This reaction produces hydrogen peroxide and releases electrons. The next comes electrochemical detection. The sensor electrode detects the flow of electric current. The strength of this current is directly proportional to the glucose concentration. Next come data processing. The current is converted into the glucose value by the transmitter. The transmitter sends this data wirelessly to a receiver. Small signals are processed automatically and stored in the sensor electrode for further analysis. Now we'll see the data processing part. The current converted into glucose by the transmitter. Transmitter sensor continuous monitoring part. So the measurements are taken in every few minutes, giving real-time trends and alerts for Now we'll see its examples and some benefits. So its example include Dexcom G6, Freestyle Libre, and its application includes diabetes management, personalized insulin dosing, lifestyle adjustment. And its benefits include it reduces hypoglycemia risk, improves long-term HbA1c control, and enhances quality of life. Now we'll see one of its question. So the continuous glucose monitor CGM measures glucose levels primarily from the options are blood plasma, interstitial fluid, sweat, and the urine. And the answer is interstitial fluid. Now we'll see the next device.
ECG monitoring device. ECG, electrocardiogram monitoring device are wearables that record the heart's electrical activity. They help in early detection of arrhythmia, arterial fibrillation, and cardiac arrest risk. Portable ECG monitors bring hospital grade diagnostics to daily life, making heart health tracking accessible. Next slide. So now I will discuss the working principle. ECG device detect the tiny electrical signals generated when heart muscles contract and relax. Electrode placed on skin picks up these voltage. The signals pass through an amplifier and filter to remove the noise like muscle activity or movement artifacts. The process signal is displayed as P, QRS, and T waves. In wearables, dry electrode and AI algorithm allow spot check ECGs or continue monitoring without clinical electrodes. So in the diagram, you can see P waves denote arterial depolarization, QRS waves denotes ventricular depolarization, and T waves denotes ventricular repolarization. Next slide. Examples and benefits. Examples are Cardium Mobile, FDA approved portable ECG device, Apple Watch ECG integrated in smartwatch. As my teammate also discussed about the smartwatches, benefits early detection of cardiac abnormalities, remote monitoring by physicians, user empowerment in managing heart health. In the diagram, you can see how ECG is connected to a smartphone to detect the ECG signals in the real life. Quiz. Which component in a wearable ECG device is responsible for detecting the Hertz electrical signals? Option A, photodiode. Option B, electrode. Option C, accelerometer. And option D, gyroscope. And the answer is in next slide. And the answer is electrode. Now my next teammate will continue with this slide.
So I will be discussing about smart rings. Smart rings are compact variable designs to track heart rate, sleep quality, stress, and activity. The ring is embedded with multiple sensors, the optical sensors, which measures the heart rate, the oxygen saturation using the light reflection, the accelerometer, which tracks the movement, steps, and activity levels, the temperature sensors, which records the skin temperature, and EDA, electrodermal activity sensors, which detect the stress response. They provide discrete health insights without bulky devices and growing popular. They are growing popular because they are comfortable and they have a variability of 24 into 7. Next. Now the working principle, it uses PPG, which is photoplethysmography. It is an LED light which emits into the skin, and a photodiode measures changes in the reflection caused by the blood flow. The heart rate and the blood oxygen levels are calculated from these light intensity variations. The accelerometer record motion, posture, and activity level. Advanced models also use temperature sensors for rhythm and movement health tracking. Data is transmitted via Bluetooth low level energy to a smartphone app for analysis. Now the examples will be Aura Ring, temperature, sleep stages, HRV, body temperature trends. The applications can be stress monitoring, recovery tracking, women health cycle prediction. The benefits can be non-intrusive, stylish, accurate, and long-term monitoring. Next, now the quiz. The question is that what smart rings primarily use which technology to measure heart rate? PPG, oscillometry, EEG, magnetometry. The answer is the next slide, which is PPG, photoplethysmography. Now my teammate will explain, continue with the further slide.
So now we'll see what blood pressure monitors are. So it's a wearable device that measures blood pressure, enables continuous tracking of hypertension, a major cardiovascular risk factor. They reduce the white coat effect seen in the hospital BP measurements, provide daily data trends for better treatment and decisions. Now we'll see its working principle. So it includes oscillometric method. A cuff inflates and then deflates gradually. Pressure changes in the cuff caused by arterial pulsation are recorded. Systolic and diastolic BP are calculated based on these oscillations. Cuffless optical methods, or as called modern variables. It uses PPG plus ECG to measure pulse transmit time, PTT, the transmit taken for a pulse wave to travel between 2 points. Shorter PTT is equals to higher blood pressure, and lower PDT is equals to lower blood pressure. AI algorithms calibrate the system, providing continuous non-invasive BP readings. Now we'll see its example and some applications.
Mm, the examples include Omron HeartGuide FDA approved a smartwatch style baby monitor and applications include remote hypertension care, elderly health management, and benefits are accurate, non-invasive, user-friendly for daily life. Next slide. Now we have the last question for our presentation. It is in cuffless variable BP monitors, blood pressure is estimated using first oxidation in inflatable cuffs, second pulse transit time, third muscle contraction signals, and fourth temperature variation. Let's see the answer. Answer is B, pulse transit time PTT. Next slide. Now we have the future scope of variables. It has various use in AI and machine learning and IoT integration, such as cloud connected variables for real-time physician monitoring, miniaturization, which is smaller, more powerful devices with multi-sensor capability, and it will be more personalized, such as custom recommendation based on continuous data. Next slide. Now we have reached the end of our presentation. That is the conclusion. The wearable health devices are transforming preventive and personalized healthcare. They empower individuals with real-time health insights while supporting doctors in remote monitoring. And future advancements in AI, IoT, and sensor technology will make wearables even more integral to healthcare system. Next slide. Thank you for being here and watching our presentation.